Today we are going to see about cayley Hamiltonian theorem. So our question is, verify the theorem of the matrix A 1 minus 1 2 2 minus 2 1 3 3 2 minus 3 and compute A inverse. So we have to verify this is a cayley Hamiltonian theorem, and we have to compute that, we have to find the A inverse value. So first we have to find the characteristic equation of matrix. Whatever the theorem given, we have to find the characteristic equation of the matrix. So for this cayley Hamiltonian theorem, what is mean by cayley Hamiltonian theorem means the characteristic equation which satisfies its own characteristic equation is called cayley Hamiltonian theorem. See here. So the characteristic equation of matrix A for this matrix is, this is the easiest way to find the characteristic equation. So our characteristic equation we have to find means, for three values or 3 cross 3 matrix, we have to put the lambda cube and s1 lambda square and s2 lambda s3 equal to 0. We have to put here alternative minus, plus and minus. So we get this lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. So we have to find the values of s1, s2 and s3. s1 is nothing but the addition of diagonal matrix. 1 plus 1 minus 3 is minus 1, and s2 is, we have to take the minor of the principal diagonals, determinant of the minor of the principal diagonal. So this one and this one we have to take, and we have to take the principal minor. So we left this term and upper term. For example, this one and this one are getting cancelled and we get this term plus, and for 1 we have to eliminate this term and this term, we get 1 2 3 minus 3, and for this term we have to eliminate this one, and 1 minus 1 minus 2 1. So if we add find the determinant of this values means minus 3 minus 6, here minus 3 minus 6 plus 1, this is 1 is 2, and minus if we put means minus 2, so minus 19. S3 value is nothing but determinant of A. So it is very easy to find the determinant value of A. For example, we put the determinant value means, for here 1 into, we strike out this term, and minus 3 and 3 2s are minus 6, plus here minus already given, so plus 1 into, and if we strike out this term means 3 2s are 6, minus minus plus 3 2s are 6 minus 9, plus if we left this terms, this one and this one means we get 1, we get terms as 4 we left this two terms for finding diagonal. So 2 2s are minus 4 and minus 3. So if we simplify means 1 minus 9 plus 1 into minus 3 plus 2 into minus 7, we get means we get this 26 minus 26 as a value. So substitute the values in the to verify the Hamiltonian theorem, we take this characteristic equation and substitute the values instead of s1 s2 and s3 means we get lambda cube plus s1 is minus 1, so plus 1 lambda square plus minus 19 lambda minus s3 equal to 0. So lambda cube plus lambda square minus 19 lambda minus minus plus 26 equal to 0. So instead of lambda we have to put a. So a cube plus a square minus 19a plus 26. This is the value of single number. We have to add with the matrix. So we have to replace it one as a I. So if we multiply with I for this term, we get in the matrix form of 26. So we have to find the a square term. So it is for to find a cube, we have to find the a cube value, a square value and a value and I value, and substitute means we get the answer as 0. So for finding a cube is written as a square into a. So for finding a square, we know that the a value is this one. So if we multiply means we get this form like this, and we find the a square. After multiplying this a square, multiply with a means we get a square. This is the a square value, and multiply with a means we get this terms. So if we multiply means we get minus 18, minus 21, 42, minus 52, minus 16, 64, and 74, 45, and minus 104. Then what we do means we find out the a cube value and a value and a square value. We have to substitute in this forms. So this is the a cube plus a square value minus 19 into a means we have to multiply 19 into a, we get this term, and plus 26 into I means we get this term. So if we add the whole terms, if we get the values of a cube, a square, a 19a, and 226i means we get this term like this. And if we add the term means we get the answer as 0. So it satisfies its own characteristic equation. So it is a cayley Hamiltonian theorem. So then after that we have to compute the a inverse value. So we have to find the a inverse term. So our a inverse, how to find the a inverse means multiply that characteristic equation. So we get the characteristic equation as this form, and if we multiply with a inverse means we get both multiply by both side a inverse means we get this terms getting cancelled, and a square plus a1 minus a power 1 19i plus 26a inverse equal to 0, and 26a inverse equal to 19i minus a square minus a. We know the value of I is 1 0 because it is a 3 cross 3 matrix. We substitute 1 0 0 and 0 1 0 0 0 1. Minus a square is nothing but we already find out that value, and a is given in the question. So if we minus this values means we get here 26 a inverse equal to, we get this values, and a inverse equal to 1 by 26, 9 minus 1 5, minus 3 9 7 7 5 1. This is the solution for this question. Hope you all understand, and thank you.